Hi everyone and welcome to my channel. In this video, my topic is differentiation. This is really something that's covered in AdMath, and when you move on to pure maths, you will see that we do it as well, but we do more complex questions. So it's really started in Form 4 and Form 5. In this video, I plan to go through the basic rules of differentiation as well as a lot of complex worked examples. So please stay tuned to see what I have in store. Differentiation. Now these are the basic rules. There's the constant rules, meaning that if it was just a number, the differential of that is 0. There's the power rule, meaning if it was a value raised to another value, a variable raised to some value, this is what will happen. There's product rule, quotient rule, and chain rule. These I plan to go through in a little more detail. But these are the two that I want to cover now. Right? So say for example, I had y is equal to 4x cubed plus 2. This actually is telling me that I have one value here with an x, that's x to the 3, and this value 2 is a constant. It has no x here. Or we could be a little extra and say, well, x is really to the 0. We can't say that, but I will just ignore that for now, right? Now, if I want to differentiate this, then my second line will be d something over d something else. Now, you're always supposed to put the value that you have, the letter that you have here at the start and the first line, and the letter that you have here that it's written in terms of, which is x, in the second one. So in my differential of this equation here will actually be dy dx is equal to, and what will I do here now? So for here now, I have 4x to the 3, that will follow this rule here. 4x to the 3 really means 4 is my coefficient and x, this 3 here, is my power, this n. So this n from on top here will multiply by my 4. So I'll get 4 by 3 here as my coefficient. I'll write back my x, and now I will raise it to the power of not 3 again, but really 3 minus 1. So that will end up being 12x squared. Now let's differentiate now the 2. I'm not done differentiating this 2. 2 is a constant, so this is constant root. And what they're telling us here is that the differential of a constant is actually 0. So this would actually be plus 0 here, and well, of course, you could put plus 0 here, or you could just put nothing else. And this is the answer, right? So let me just recap what I did there. If I had y is equal to 4x cubed plus 2, to differentiate it, I will simply write dy dx, only because I have a y here and an x here, right? And differentiating it now, I will simply multiply these two powers. 4 by 3 is 12, x to the 3 take away 1, 2, and that is my answer, the differential of my first sum. Now let me move on to another one. This question now says that what if I had a is equal to 4b to the half, right? So a is equal to 4b to the half. So differentiating this again, I wouldn't put dy dx, I'll actually put dA db, because I have a written in terms of b. So I'll write back my a here and I'll write back my b here, right? So now moving on, again I differentiate. This will be 4 multiplied by a half as my coefficient, write back my b, and it will be a half minus 1. So now simplifying this now, my next line will actually be, this will go to be 2b to the minus a half. Now we try not to leave it like this, so I will write 2 over b, and a half means, well, root. So this is my answer, or I could write 2 over b to the half. So either one of this is the answer. So this is my second question. Now for me to differentiate my third one now, again, I need to just simplify this, right? So of course my second line will then be, well, I could simplify it before I move on to my second line. My second line would have been a differential line, right? So let me simplify this. This simply means, this root here means a half. So it simply means 7x to the 5 on 2. So once I have it written like this, it's now nice and easy to differentiate. The y dx again, only because I have a y here and an x here, right? The coefficient will be 7 by 5 over 2. X to the 5 over 2 take away 1, which turns out to be 35 on 2. X to the 3 on 2. Which turns out to be 35 on 2 x, I'll leave this on top, root here with a 3, or I could write 35 all over 2. I could put the square root here first and then put the cube. Now notice that all of this is happening just to the x, right? It is not happening to the 35 nor the 2. So that is why we just have it in brackets like this, right? Okay, so this is the end of my third example. Now let me move on to my fourth. Fourth example still falls into the realm of these two rules, right? Is this. And now I simply have y written in terms of all these values with x. So my second line will be dy dx, and it's just simply a long sum, but it's really not that challenging. Differentiating this, I'll get 3 by 4, 12, x3. Let me just write that better. Right, minus 2 by 3 will be minus 6, x2. This will be 2x. This minus x will actually just turn out to be minus 1. Right? Because I will drop this x value. So this is my fourth example. I hope you all understand it. Now let me move on to questions where we have product rule and quotient rule. Example 5 now is this. Now we have here a bracket here and another bracket here. So it means that we are multiplying. So that means that we will possibly use product rule. Product rule is when you have one function multiplied by another function, just like this. They put it as f of x by g of x, right? Now some formulae, you might see it with a u and a v. That's usually how I teach it. So then you will put u dash by v plus v dash by u. Now you can learn it this way, this red way here, or in this black line like this. It doesn't matter whichever way, right? I tend to rearrange it though. I usually start with v by u dash plus u by v dash, right? Meaning I will write my product rule like this. When I teach this topic, I tend to use this formula instead. It doesn't matter whichever one you use, it just depends on whichever one you understand and once it's one of the correct ones, right? So now, moving on, if I were to do now, find the differential of this, I would have to again separate this into a u and a v. So this would be my u and this could be my v. So then I'll write u is equal to 5x cubed minus 2x plus 1. V is equal to 4x squared minus 7. Now it's always good to work separately with these. And then I find du dx, which is 15x squared minus 2. And of course the v dx, which is 8x. Now, once I have this here, then I could substitute into my equation. In this equation here, where I have v by du dx and then u by dv dx, now I just have to substitute. Just substitute in here now. This is my v. My du dx will be 15x squared minus 2. Substituting this and this. Put them at my plus. U now would be all of this. So 5x cubed minus 2x plus 1. And multiplied by dv dx now, which would just be 8x. Now this is just a big expansion, right? So you have to multiply these two like this and so. And just keep going. Right, so this is just expanded. Now simplifying this now, I see these two will add up to 100 x to the 4, so that gets rid of these two. I have a whole set of x squareds, and when I work these out, these three values out, I will get minus 129x squared. Then I will remain with, oh sorry, this is supposed to be 8x here. Let me just write this over here. I'll have plus 8x here, and then of course I'm left with a 14, so this is my answer here. So it is 100 x to the 4 minus 129x squared plus 8x plus 14. So this is the end of my fifth example. Now let me move on to an example in quotient rule. The only thing that we need to have is really the division. So I have here a numerator here and another value here. So this numerator, I will call this as u and I will call this bottom as v. So then what it says for quotient rule is that if I have, this is my v here over my u here, then I will have to say v by du dx. Now it's the same thing what they have here, minus u by dv dx, and then I'm going to divide by v squared. Right? So you could use my formula here, which is in blue. But when I say mine, this is the formula that I learned when I was in school. Or you could use this formula here that I have here in terms of g of x, f of x and g of x. Now substitute in here now. I get u is 8x cubed, v is 6x squared minus 1. Differentiating these two. Now substituting into the formula, v by du dx minus u by dv dx, all divided by v squared. it actually becomes this. So v will be 6x squared minus 1 minus u, which is 8x cubed by 12x all over 6x squared minus 1 all squared, right? Because it's v squared. Now simplifying the numerator here now, I will end up with 144x4, this is this by this and this by this, minus 24x squared, and these two multiplied will end up with minus 96x4 all over, and I'll just leave this like this, 6x minus 1 all squared. Now simplifying, I will get 48x4 minus 24x squared all over 6x minus 1 all squared. I could factor out 24x squared if I wanted, and put 2x squared here, minus 1, and then put 6x squared minus 1 all squared. So this could be an answer, or this one here as well, right? So either one. So everybody, this is the end of my 6th example. Now let me move on to the next rule, which is chain rule. The chain rule is actually a function of a function here, right? So for example, it could look like this. Y is equal to x cubed minus 4x squared plus 7 all raised to the power of 10. Now, of course, we can take this whole expression here and raise it to the power of 10, get a million values like this and differentiate each one. Yes, we can do that, right? However, that is not what we want to do. In this particular sum, all it's telling us is that what we need to do is use this as one value, right? So let u be the inside value. So I'll get this. And then I will say, well, then y will actually be u to the 10th power. So then let me work out what is du dx. Du dx would be the differential of this expression here, which would be 3x squared minus 8x, and the du will actually be the differential of this red expression here, u to the 10, which is 10u to the 9, right? Now, how do I get my answer, which is to differentiate, right? I want to get the y dx. Well, that's simply by taking the y du and multiply by du dx. What will happen? The two du's will cancel. So I'll have 10u to the 9 multiplied by, well, 3x squared minus 8x, which works out to 10. What was that again? U was this here to the 9 and 3x squared minus 8x, right? Remember, I have u is actually equal to all of this here. So that is why when I say use u to the 9, that is how I could get it back. I'll get 10u to the 9 here by this value here. Everyone, is the answer for my 7th example. The way that I could do this is I could take the differential of the value here. Now, another way of applying this formula, I should say, is if I had an expression raised to the power n, the differential of it will actually be the n multiplied by the differential of the inner expression multiplied by the expression itself raised to the power of n minus 1. Now, using the same formula here, I could apply the same procedure to this equation here and get my same answer. So let me show you how. It would work out to be dy dx. Now I'm trying to see if I can get the same answer here, right? It actually be n, right? What is my n? My n is 10. Multiplied by the differential of the expression, which is the differential of the inside here, which will actually be 3x squared minus 8x. So that I've covered this piece and I've covered this piece. So now let me cover this piece. ax plus b, which is the whole expression that I was given, plus 7 raised to the power of n minus 1, which is 9. And actually that's exactly what I have here, right? It's just arranged differently, but that's okay. Multiplication is commutative, right? So now when we move on to another example to explain this even better. This is my 8th example now. So let me show you how I would apply this. If I was given this, y is equal to this is the same as saying y is equal to 1 on x squared minus 3 to the 1/5, which is the same as actually saying let me write it at the bottom here, y is equal to 1 on, well no, I should put it like this, x squared minus 3 to the minus 1/5. So if I have this now to differentiate and I'm following this same procedure here, what I would do is I would just write the y dx is equal to, now what do I need to get here, guys? I need to get my n. My n is this, so I have to multiply here. So I will write that here as minus 1/5 by, what do I need to get here now? My differential of this equation, which is the differential of this equation, which will actually be, what's that, 2x. And lastly, I need to get this, which is this raised to the power of that, which is actually this raised to the power of that. Oh, excuse that. Right? And I will get x squared minus 3 raised to the power of minus 1/5 minus 1. Now simplifying this, I'll get 2/5 x squared minus 3 raised to the power of minus 6 on 5, which again will end up being x squared minus 3 raised to the power of 6. I can have a 6 here and I can have a small 5 here. Right? Another way of writing this would be minus 2x 5. I can have the 5 inside instead. So x squared minus 3 to the 1/5, and then I could be raising this to the 6. Right? So either one is okay. This has taken me to the end of my video. So I got to go through 8 worked examples and I went through all these rules here. So I hope that you understand what I did, and please feel free to like, share and subscribe. Take care everyone.